So we've seen how atoms can share one pair of electrons. Atoms can also share more than one pair of electrons. So if we try to do a Lewis structure for oxygen. So oxygen is one of those diatomic elements. And so we're going to have two oxygen atoms. And how many valence electrons does each oxygen atom have? 6. So let's put a couple of pairs, oops, and then a single over here. So I'm drawing the Lewis structure for each oxygen atom. And Lewis theory is saying, well, we're going to predict and explain how these two atoms bond together by having them share valence electrons until they get an octet. So we can say, well, we've got 6 and 6. If they share this pair that are right next to each other here, then they both count the shared electrons. So this oxygen counts 2, 4, 6, 7. And the other also has 7. And so this is better. 7 is closer to 8, but it's still not 8. So what's going to happen is they each have another electron here. They can share those as well. So they're going to share 2 pairs of electrons. And so now the oxygen on the left counts this pair and this pair, so that's 4, 6, 8. In this way, they both have 8 valence electrons. That's kind of an ugly drawing, so usually we draw it like this, a double bond between the 2 oxygens, and then 2 lone pairs on each oxygen atom. Any questions? For things like hydrogen and bromine, chlorine, fluorine, they can share one pair of electrons and achieve an octet or the duet for hydrogen. But for oxygen, that's not enough. They need to share 2 pairs of electrons. Sharing 2 pairs of electrons is called a double bond. With the double bond, as this kind of makes intuitive sense, if they're sharing 4 electrons between them instead of just 2, that's going to pull those 2 atoms closer together, so a double bond is going to be shorter, and that bond is going to be stronger than if it were a single bond. We can look at measurements and see that the distance between oxygen nuclei in an oxygen-oxygen double bond is 121 picometers, but in a single bond it's 148. And so we see that sharing more pulls those 2 atoms closer together. Yes? No. No. These numbers are just to illustrate the point. You should know that double bonds are stronger and shorter than single bonds. And if you think about it, you can think of sharing as having something in common with another person. The more you share with that person, the closer you are and the stronger the bond between you, right?
Will we reflect that distance when drawing Lewis structures?
No.
Okay.
No, we don't consider that when drawing Lewis structures. So let's do nitrogen. Nitrogen is another diatomic element. So here's one nitrogen atom and another hydrogen atom. And how many valence electrons does nitrogen have? 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'm drawing them in a particular way because I know what I want to do with them. So these 2 nitrogen atoms are going to try to share electrons so that they can both get an octet. So if we share 1 pair of electrons, now this nitrogen has 2, 4, 6. That's more than 5, but not good enough. So let's share another pair. Now they each have 7 electrons because both of them count the shared electron. So what happens is they need to share 3 pairs of electrons. Now this nitrogen counts all the bonding electrons, 2, 4, 6, plus its lone pair, 8. So usually when we draw a Lewis structure for nitrogen, we show the triple bond as 3 lines, and then we put the lone pairs on each atom. So remember, when you see a line in a Lewis structure, that means a pair of electrons being shared. So you count, there's a lot of counting by 2s in Lewis structures. So 2, 4, 6, 8 for this one, 2, 4, 6, 8 for that one. And that's a triple bond. So my husband and I have a triple bond because we have 6 children between us.
Oh, God.
Yes, there's 6 of them. It's, yeah, I love the expression on your face. It's just how it is. And this is why I enjoy coming to work, because this is so much easier than being at home. This is good. I'm happy to be here. You guys are, I love my children dearly, but you can just imagine. Anyway, so we have this triple bond between us. So a triple bond, 3 pairs of electrons. Triple bonds are shorter and stronger than double bonds. So if we look at the nitrogen-nitrogen bond, a triple bond has a distance of 110 picometers. The double bond is 124. A single bond between nitrogen atoms would be longer than 124. Again, you don't need to know those numbers. Just know that a triple bond is shorter and stronger than a double bond. So nitrogen is a diatomic molecule. And those 2 atoms are held together by a very strong short triple bond. And so nitrogen is very unreactive because that bond between them is so strong.